Hello. This is where we left off last time. I gave you the problem of a magic triangle, and the sum of this side has to equal the sum of that side, and they have to equal the sum of this side. So all the sides have to total up to the same number. So this is the way I left it, and when I'd said goodbye, I looked at what I'd left and I said, "Oh, Larry, look what you've done here. You've left it with 12 and 12 and 7. And you first have to consider, well, now what could I do? I've got two numbers at the same. Is there any way that I could make this into 12? So I look at it and I say, oh, I could just move this number over here. Let's put this one here because they'll still going to be the same three numbers. They're still going to equal 12. And now I have 6 and 6, and that's 12. And I said, well, that was pretty easy. And I looking at it, and I say, in the old days when I would look at it, I'd probably say, hey, I've got that one done. What's the next one? But now, having done those problems about the knights in the king's hunting lodge, and realizing that some problems have 3 or 10 or even 17 different unique answers at work, I say to myself, hey, I better look and see if there's a different magic sum for this than 12. So when I look at it, I say, look what you've got here, Larry. In the corners, the numbers in the corners get used two ways. The numbers in the middles only gets used one way. So I've got the three biggest numbers there and the three smallest numbers there. And what would happen if I traded them out a bit and moved them and put the small numbers in the corners? And there we go. Did I get it there? No, I didn't. I see that right away. This is 9, that's 8, and that's 10. So I've got 8, 9, and 10. Now there are three numbers, and my guess is now that what I'm looking for is the middle number. In other words, the number that sort of balances those out. And so I look at this and see, is there a way that I can get 9 each way? Well, I have 9 each way here. What about there? And I say, oh, look at this. I'll just trade these two numbers. And I get 9 and 9 and 9. So here we've got two magic sums. Could be 9 each way, or it could be 12 each way. Now, part of me, once I see that, is I'm thinking, well, wait a minute, I don't have very many numbers. I have a feeling that there might only be those two. The low numbers in the corner, but maybe a combination of low and high in the corners could work. So I'm going to leave that with you. Now, I was going to, I say was, as soon as you hear that word, you know I've changed my mind. I was going to spend some time looking at this, the basic magic square, 3 diagonals and the rows, and we don't know what the magic sum is, and I was going to talk about that with you, and I realized that it would take longer to do than I really should on one of these videos. So what I'm going to do is save this till next time. Now, if you've already done this, then you're all ready for next time. But it would be nice if I gave you a problem. So I'm going to give you a bigger triangle problem. If you haven't done that magic square, then you've got maybe some incentive to go and look at it a little bit more and see if you can get it figured out. And we'll check both problems next time. This problem, we're going to use the numbers 1 to 9. It's a bigger triangle. And to help you, I put the magic sum. So you've got those numbers, put them on, shift them, sort them, work them, and see if you can get it to be 17 each way. So have fun. Until next time, bye for now.